Okay. So, this part right here is called the chain rule. And so you are going to use the chain rule when you have like a function inside of a function, or you can break it down into a function inside of a function, or that's also called a composition of functions. So if you're finding the derivative of f of g of x, then your derivative is going to be f prime of g of x times g prime of x. And you kind of have to see it in action before that makes any sense at all. But we are getting ready to do that. And so we got our first example there. We've got f of x equals the square root of 2x minus 3. We're supposed to find f prime of x. And this is something we don't know how to do. Well, actually, the only other way we would know how to do this one is to use the limit definition of a derivative. And I think we all agree that we would rather not have to do that if possible. We don't know how to do this at all with the rules that we have been given. So what we're doing whenever we do the chain rule is we're trying to break our function down into a composition of functions. So like an outside operation and an inside operation. So in this case, your inside part is the 2x minus 3. So that is like your g of x here. That's the inside function. And then the outside part is the square root. Now, I would, on this one, before we start taking a derivative, I would probably write it using fractional exponents instead of square roots. Because when we start doing like a power rule sort of thing, we want to have fractional exponents rather than those square roots. Some of you might be like, nah, I'm good. I just do that part in my head. That's okay. I think most kids get it mixed up sometimes. So I think it is a good idea to do 2x minus 3 raised to the 1/2 power. Make sure you have parentheses around that 2x minus 3. They are necessary. If they're not there, then what you've written is incorrect. Okay, so again, our inside part is the 2x minus 3. The outside part is the to the 1/2 power, or that's the same as our square root. So whenever I can, there's only a few things like I can for sure remember, like my calculus teacher teaching me this specific way or saying this specific thing. But one thing I definitely remember is when we learned chain rule, she used like the analogy that I feel like everybody has at least one person in their family like this. You ever got a present where somebody thinks they're funny and they've like got you something tiny, but they wrapped it in like a great big box that has a box inside of that, that has a box inside of that, that has a box inside of that, and then zip ties all over that box or something like that. Your family might not be like mine if you don't have at least one person in the family that sometimes is going to wrap something that way. So if you have that situation, you have to unwrap the big box on the outside first to get to the smaller box on the inside next, and to the smallest box on the inside last. So you have to start on the outside and you have to work your way in. So if you sort of think of the derivative as your unwrapping of the present here, we've got to take the derivative of the big box first, the outside function first. Then we take the derivative of the inside of that. Most of these we're going to look at today are just going to be like two boxes. They're not going to be But you can have chain rules inside of chain rules inside of chain rules inside of chain rules. I don't know if I've ever seen one that had like 4 levels. I think 3 is the most I've ever seen problems for. But theoretically, I guess it could go even further than that. So whenever we're taking the derivative of this, we want to take the derivative of the outside first, which is just, think of what the green box is. Think of it as something. Right? We got something raised to the 1/2 power. So if we want to take the derivative of something raised to the 1/2 power, we can just use the power rule for that, right? So when we take that derivative, we will have the stuff on the inside does not change. So you'll have 1/2 times the something, and then we got to subtract 1 from our exponent, so we'll get -1/2 there. Okay, so what we've done there is we took the derivative of the 1/2 of the raising something to the 1/2 power. But our chain rule tells us that we have to take the derivative of the f of the outside, but then we have to take the derivative of the inside and we have to multiply it out here on the end. So what we have to do here is we've got to take the derivative now of the inside part. What is the derivative of 2x minus 3? It's just 2. And so we're going to multiply this by 2 over here on the end. Now, most of these are going to require a little bit of simplification after that. Technically, if it's free response, we could stop here. We're done. But most of the time, it's going to be simplified a little bit. Keep in mind, all these things are multiplied. It's 1/2 times 2x minus 3 to the -1/2 times 2. So since those are all multiplied, I could multiply the 1/2 and the 2 together, which will give me just 1, right? So since those like sort of essentially cancel each other out, you're going to get 1. We just have 2x minus 3 to the -1/2. And then they might leave it like that. They might also send that back down to the denominator because it's got a negative exponent and write it this way, 2x minus 3 to the +1/2. Or they might write it as the square root of 2x minus 3 in the denominator there. I think you guys probably saw this on the midterm the other day on that free response question where you had to find the derivative of that function that had like the e to the x with it. Or no, maybe it was the other one. Well, both of those really. You don't have to simplify your derivative. You can stop here. But if they ask you to do something with it in the next step, sometimes it's helpful to simplify it because it gets really long for that. But any of these would be appropriate for your answer. Okay, questions? All right, let's look at our next one. We've got y equals sine of 8x. So in this case, what would our inside function be? The 8x. And so the outside that we're taking the derivative of is the sine of something, right? So when we take the derivative of this, y, we can call that dy. Dx, you can call it y prime if you want. Either one of those are the same. What is our derivative of sine? Cosine. And it is cosine of the something. Keep the something the same. Do not change it. Do not take the derivative of that 8x and make it 8 right here. It stays the same. We're not dealing with its derivative yet, right? So we just take the derivative of sine. We leave that green box alone right there. Then we have to multiply by the derivative of 8x. What is that? 8. Okay? And they're probably going to write it this way, 8 cosine of 8x. That's all you got to do. Chain rule, I'd say this type of trig chain rule, I'd say is about as simple of a chain rule as you're going to get. And then we're going to work on chain rule the rest of the week. Chain rule can get real crazy sometimes too. Like you can have chain rules with quotient rules like inside of the chain rules. Like we're going to work on this for a while, so they can be very simple and then they can get much more difficult. So we're going to look at a lot of different types of chain rule problems. Okay, here's our next one. Now, you might be looking at number 3 and saying, but Ms. Hyatt, that does not look like a chain rule problem. That looks like it's a quotient rule problem. And you can definitely do the quotient rule for this. In fact, I'm going to do this both ways so you can see what to do. So let's go with quotient rule, which we already know first, right? If we did quotient rule, then f prime of x would equal low, so x plus 1, x plus 1 times the derivative of the high. What is that? 0. A lot of people mess that up. They don't put 0 right there. Minus high times the derivative of the low. What's that? 1 all over x plus 1 squared. So since this is multiplied by 0, we're just going to get negative 1 over x plus 1 squared. It's not incredibly difficult, really, to do. It's a pretty easy chain rule, really. But what kids mess up a lot of the time is they don't say the derivative of 1 is 0. They usually say it's 1, and then they get the wrong answer for that. So another option for this, I'm not even saying it's a better option, it's just another option out there. In fact, I think whenever I was in high school, I do not know why, other than I personally do not like to memorize a lot of formulas. I would rather like figure I'm not great at memorizing things, and I would rather like figure something out, like if I understand how it works, than have an extra formula for it. But I know when I was in high school, I think I avoided the quotient rule almost altogether. I hardly ever used it because this is what I would do on almost every problem. This could be rewritten with negative exponents. So that would make it 1 times x plus 1 to the negative 1. Essentially, every quotient rule problem can be rewritten with negative exponents. Now, sometimes it just gets like more complicated, and I don't really think it's, as a teacher now that knows more than I knew when I was in high school, I don't think it's always a great idea. But you can change this to negative exponents. So if you change it to negative exponents, you can use the chain rule. You do not have to use product rule here because 1 is just a coefficient. It doesn't have an x with it. So there are times that you'd have to use the product rule, like with a chain rule in it, but you don't here. So f prime of x, if we're using the chain rule, our inside part is x plus 1. Our outside part is this something to the negative 1 power. Obviously, like this, I might even erase it. That one right there is not necessary to write there. So if I'm taking the derivative of something to the negative 1 power, I multiply out front by negative 1. I keep what's on the inside the same. I raise my exponent, or subtract 1 from my exponent to get negative 2 right there. And then I still have the inside. I have not taken the derivative of that yet. What is the derivative of the inside stuff? It's just 1. I'm going to write it so you know I didn't forget it, but it's not all that necessary here. And so if I have this, that is a negative 2 power, so it can just go back down to the denominator. and it will look like this, which is the same answer we got with quotient rule. Okay, questions? All right, so example 4 is very much like what I just made you guys do on the warm-up, right? So an option is to use Pascal's triangle to expand that and then take the derivative using the power rule. But as we already saw on the warm-up, which was actually probably easier than this problem, right? Because it was only 4th power and the numbers were a little smaller. That's terrible. And if you don't have a calculator, your likelihood of getting to the correct answer at the end is almost nothing, right? So, if we use the power rule, chain rule on this, um, 2x minus 5 is our inside. The 2 to the 5th power is our outside. So if we're going to take our derivative, we'll have f prime of x equals 5. Stuff on the inside stays the same. We don't touch it yet. To the 4th power. So it'll look like that. But then we must multiply by the derivative of the stuff on the inside. What's that going to be? 2. Okay. Remember, all this stuff is multiplied together. So I can multiply the 5 and the 2 together, and I'll get 10 times 2x minus 5 to the 4th power. Another thing for this is if they give you a problem like this on the AP exam or on one of my tests, the answer choices on a multiple choice problem are probably going to look like this. So if you were to expand it and take the derivative with the power rule, you would get that big long string of stuff, right? And then to get it to match one of these answers, you would have to factor all that back and talk about a problem that would be time-consuming and difficult. That would take forever, right? So a problem like this does not necessarily have to be done with the power rule, but if they make the answer choices look like this, it becomes almost impossible to do it any other way because it would just take so much time, and one tiny error would do you in there. So, but much faster if you just use that chain rule. Everybody good there? All right. Here's our next one. Put the oh, there we go. Okay, so we got y equals 2x minus 3 tangent of x squared. Where's our chain rule on this? What's our inside? What's our outside? Okay, so we got this x squared is our inside part. Our 3 tangent is our outside part. What about that 2x? It's separated out by a minus sign, so it's just 2. We just take the derivative of it, right? So yes, and parentheses can be very important here. So whenever we take the derivative, well, actually, you can do it either way. You can put that negative with the 3, or you can keep it on the outside. I would keep it on the outside. If you put it on the inside, it's like a plus a negative 3 right there. So, so the 2x derivative of it is just 2. It's very, very simple power rule, right? For the 3 tangent x squared, we've got to take the derivative of that 3 tangent. What is the derivative of tangent? Secant squared. 3 is just a coefficient, so it just stays the same. 3 secant squared. Leave the inside alone. Don't do anything to it. It stays the same. but we must multiply by the derivative of the inside. What would that be? 2x. They probably will not do much with this except for here they're probably going to multiply that 2x by this 3 up here. So that'll give you minus 6x secant squared of x squared. And they'll probably leave it at that. So sometimes part of the equation needs a chain rule, but another piece may not for that. All right, let's look at this one. Yes. So we got f of x equals the cube root of x squared minus 1 squared. Now, there are two different ways you can look at this problem. If I try to do this problem, what's my inside part? X squared minus 1. And then, what's the outside? This would be an example of like a triple chain rule, but we can get around it. So if you leave this equation like it is right now, it's got like a triple chain rule. You got the cube root you got to deal with first, then the square on the inside, then the x squared minus 1. But there is a way around it, because if I have the b root of x to the a power, how can I rewrite that? X to the a over b. So what I could do here is I could rewrite this as x squared minus 1 to the 2/3 power. And if I do that, I will avoid having to do the triple chain rule. Because triple chain rules are not easy. Possible, but not easy. Plus, a lot of times if you do that, like getting it to simplify to what they actually have as the answer is also difficult too. So if we do it this way, it'll be a lot easier because this is still our inside, but now we just have one outside here. So our derivative here, to take the derivative of something raised to 2/3 power, we would have 2/3. Leave the inside alone. Don't change anything there. We've got to subtract 1 from 2/3. What will we get? Negative 1/3. But we did not do anything with that inside part. We've got to multiply by the derivative of that inside part. What's that going to be? 2x there. When you have negative exponents and fractions and all of this stuff, I think it is helpful to put everything over 1 before you start simplifying. So I've got 2/3 times this stuff over 1 times this stuff over 1. So since I've got a negative exponent right here, I can send it to the bottom, right? And that would leave just the 2 and the 2x in the numerator. So that's going to be 4x in that numerator. And then in the denominator, there's a 3. And then I'm moving my x squared minus 1 down to the bottom and giving it a positive exponent. They may leave it like this. They may also change it back to a root like so. It'll probably be left one of those two ways. Okay, questions? All right, let's look at 7 here. Okay? This can be done one of two ways. You can do a quotient rule. But if you do a quotient rule, it's going to be a quotient rule with a chain rule involved. Because 3x minus 4 to the second is going to require a chain rule. I would not do that. I would use negative exponents. I would make this negative 5 times 3x minus 4 to the negative 2 power. If there was an x right here, you may just want to go ahead and do quotient rule. If like there's an x in that top part. But because this is just a coefficient right here, I can make my inside part 3x minus 4. I can make my outside part the negative 5 times something to the negative 2. Somebody want to try this one?
I'll try it.
All right, go for it, Xander.
10 times 3x minus 4 to the negative third times 3.
Perfect. Very good. So we do just power rule here. That 3x to the 4 stays the same. You don't touch it. Then multiply by the derivative of the inside, which is just 3. They're probably going to clean it up a little bit here. Remember, everything's multiplied. 10 times this stuff times 3. So you can do 10 times 3 will give you 30. And you're going to send that negative exponent back down to the bottom. So they'll probably do 3x minus 4 to the negative. I'm sorry, positive 3. There. There's a chance they might leave negative exponents. It's hard to tell how they're going to leave it on the multiple choice question, but that's 3 right there. Now, 8 will be the most difficult one that we do today. What do you think we're going to have to do on 8? We're going to have to do a product rule, but it's going to involve a chain rule. So what I always suggest with square roots is rewrite them as fractional exponents. So I'm going to rewrite this as x squared times 1 minus x squared to the 1/2 power. So you have two things being multiplied. Both of them have x's in them. You've got to use a product rule on this. So when you are taking your derivative, you will have your first piece. And that would be just our x squared. But you've got to multiply by the derivative of this stuff. But the derivative of this stuff requires a chain rule, right? So whenever you take the derivative of this stuff, you're going to have 1/2. Inside part stays the same, 1 minus x squared to the negative 1/2. So we've taken the derivative of the 1/2 power part. But now we got to multiply it by the derivative of the inside part. What would that be? Almost negative 2x. Okay? It feels like we should be done. But we have only done half of the power rule. This was our first term. All of this stuff right here, all of that stuff was just the derivative of the second part, right? So we've got to do plus the second part, 1 minus x to the 1/2 power, times the derivative of x squared, which is 2x. So just to make sure everybody's with me, like if this is our f of x, and this stuff in the red box is our g of x, this was f times all of this stuff was g prime. It took a chain rule to get that answer. And then this stuff was our g, and then this is our f prime.
Why does it g have a 1 minus x squared?
Oh, it should. It needs a square right there. Thank you. Everybody with me there so far? Now, for response, you can stop here. More than likely, you're going to see stuff like this on multiple choice where you got to simplify or do something else with it where it is going to be to your benefit to simplify. So first, remember that all of this stuff is multiplied together. So I've got x squared, 1/2, and negative 2x. I want to multiply those together and kind of write it out front. So the 1/2 and the negative 2 is going to give you a negative 1. And then you got an x squared and an x. That'll give you x to the third. And then the 1 minus x squared to the negative 1/2 will go here. So I was multiplying this, this, and this together to get that negative x to the third. And then you just kind of keep this part right there beside it. The second part doesn't really have much you can do, but they would probably write 2x out front like that. Again, they're probably not going to stop here. So a trick that I like to use for this, it seems complicated the first time that you see it, but it is very helpful for these, is notice that I have right here, where's my highlighter? Right here, these two pieces have the same like inside part, right? So what I want to do is factor out the lowest exponent of that expression, okay? So that will look like this. I am factoring out, I'm dividing by 1 minus x squared to the negative 1/2, and I'm dividing by 1 minus x squared to the negative 1/2 here. Okay, both places. And then I'm writing it out front, 1 minus x squared to the negative 1/2. So much like a greatest common factor, like if you had 8x squared plus 16x, and you were doing like divide by 8x here, divide by 8x here to write 8x times x plus 2, right? Like, this has nothing to do with this problem. I'm just trying to show you we're doing the same thing here. You're factoring out a greatest common factor. This is just a much more complicated looking example of it. So if I have that to negative 1/2 to negative 1/2, these two things just cancel each other out right there, right? And I just have negative x to the third. But that is not going to happen over here because I have a positive 1/2 and a negative 1/2. For this, the negative 1/2 could move up to the top, right? So that'd be up here, 1 minus x squared to the positive 1/2. And what am I going to get if I multiply 1 minus x squared to the 1/2 times 1 minus x squared to the 1/2? 1 minus x squared, because you add your exponents there. 1/2 plus 1/2 just gives you 1. So this gives me 2x times 1 minus x squared just to the first power. So magically those fractional exponents are gone in that second set of parentheses, right? Which is wonderful because now we can just distribute and combine our like terms here. 1 minus x squared to negative 1/2. And then we're going to get negative x to the third plus 2x minus 2x to the third there. And 1 minus x squared to the negative 1/2 times, that's going to be, they usually write it like this, 2x minus 3x to the third, although you could do negative 3x to the third plus 2x would be okay as well. And most of the time, they will send that negative exponent back down to the bottom. So you'll either have 2x minus 3x to the third over 1 minus x squared to the 1/2, or they may even change it back to a square root. Or on this particular problem, they may even factor out an x. X times 2 minus 3x squared over the square root of 1 minus x squared. It just any of those on that last line might be a way that they'd leave your answer on the multiple choice. Okay. Questions there? That's the hardest one we're going to look at today. There's ones that will be a little trickier coming in your future, but I do have a couple more we're going to do, but they are pretty simple. There. Any questions on that one? Okay. These are going to be very easy because the derivative of a natural log function. You can write this first one down if you want, but this is the derivative we already knew for a natural log. Just the derivative of natural log of x is 1 over x. This one is your chain rule of the derivative of the natural log of x. If you're taking the derivative of the natural log of u, where u is some sort of function, it may not be x, it might be x squared, it might be 3x plus 4. It might be natural log of 3x plus 2, which we're about to see. Then we would do 1 over u times the derivative of u, which either could be called du over dx or u prime. So I'll give you a second to write that down, and then we also have that first example right there, natural log of 3x plus 2. Okay, so if we're taking the derivative of the natural log of 3x plus 2, 3x plus 2 is our inside of our function, natural log is our outside. So when we take the derivative of a natural log, our answer, if it was just natural log of x, it'd be 1 over x, right? So if it's natural log of 3x plus 2, our derivative is 1 over 3x plus 2. But this stuff right here is still our inside part. So the derivative of 3x plus 2 would be just 3. I like to put this over 1 so I can combine it, and then I would have 3 over 3x plus 2. Will that simplify any? Nope. I was hoping somebody would suggest it, but you cannot cancel it. Why can we not cancel the 3's? Not necessarily the x, but it's that 2 right there. If you're adding or subtracting anything to what you're trying to cancel, you cannot cancel it. There, so you would just leave it like this. Okay? Here is one that is a little bit different. Okay, we've got f of x equals natural log of x to the 4th power. What is your inside on this one? The natural log of x is the inside. the outside is the to the fourth power, right? So when we take this derivative, f prime of x is going to be 4, leave the inside alone, it's natural log of x, to the third power, so we left that inside part right there alone. Then we have to multiply by the derivative of natural log of x. What is that? 1 over x. Alright, you may want to put this over 1 so you can think about combining those. You'd probably just write this for natural log of x cubed over x. If we're going to look at natural logs, what usually goes with natural logs that we also look at? E. So we have to look at E as well. So our derivative of an exponential, a derivative of e to the x is e to the x. It's going to be a little bit different when you have a u right here. That u just represents anything besides just a singular x. The derivative of e to the u is e to the u, but you got to multiply it by the derivative of whatever that exponent is. Yeah, this is the last.
I'm trying to conserve it.
Yeah. We've just got this. This is our last example.
Okay.
I'm pretty sure. Yeah. The only thing else I've got is the assignment numbers. So, well, no, let's write. Forget that you're copying. It is the derivative of e to the negative 3x. They should already know about that, but several of them missed a very easy question on the check-in because they rounded to 3 places when it told them to round to the hundredths. In their defense, I do have them round to 3 decimal places on almost everything. They were doing it on Desmos, which rounds to 3 places. I can see how it happens, but many of them definitely did not know that.
What is that supposed to be? Like,
That's elementary school for sure. Yeah.
it's okay.
Yeah. Yeah.
Sometimes you forget how to multiply.
Yeah, we forget things. It's okay. I was just happy some of them did almost get the right answer. So now that I've taught them that, hopefully they won't make that same mistake again. But because it was a question we should have gotten right, only 20% of the kids got it right. But then I realized a lot of them were. Okay, so let's do this one real quick. Last one. The derivative of e to the negative 3x. This is going to be you. Hello? Yep, I'll send her up. You're welcome. Bye. All right. So, derivative of this is e to the negative 3x, but you've got to multiply by the derivative of the negative 3x, which would be negative 3. These two things are multiplied. Normally, they're going to write that negative 3e to the negative 3x this way. You might even see it like this, negative 3 over e to the positive 3x. They might try to get rid of those negative exponents.
So you just multiply by the exponent?
Derivative of the exponent. So your inside part on that is your exponent.
Okay.
Yeah. Okay. So, the assignment, let me look at what I've got on Canvas and see if that's the same, and look at the questions. I can't remember. It's several, but several of them are fast for this. Okay, we'll go with what I got on Canvas. Canvas says for you to do 7 through 25 odd and number 26. So let's do that. cut a few out there. 'Cause yeah, that is your homework. And you also have your FRQ redemption on Friday that you're working ahead to prepare for, and you've got your test corrections for that.